Hi class, this video is a tutorial on lesson 4.8, which is all about isosceles triangles and the isosceles triangle theorem. We also call this the base angles theorem. And so the main idea, and again I've already filled out my vocab, but you guys will probably want to do that before you complete the examples. But the base angles theorem basically says if I have an isosceles triangle, which again remember means I have two congruent sides, then the base angles are congruent. And the base is considered that third side that's not congruent to the other two. So in my triangle here, if these two sides are congruent, my base angles would be angle A and angle C. So in an isosceles triangle, my two base angles are congruent. And this works the other way around. If I have two angles that are congruent, then this is an isosceles triangle. Okay, so we're going to use that information to help us on these three examples here. Okay, so we've got finding the measure of angle H. So this is an isosceles triangle because I have two congruent sides, which means my base angles, which would be these two, are exactly the same. So I don't know what they are, but I know they're the same. So I'm going to make them both be x. And I know by the triangle sum theorem, they have to add up to be 180 degrees. So 2x plus 48 equals 180. So if I subtract 48 from each side, I've got 2x equals 132. And if I do 132 divided by 2, I'll get x is equal to 66 degrees. So the measure of angle H equals 66 degrees. And 2 is referring to this guy here. So again, I've got an isosceles triangle, meaning that base angles are congruent. So the base is this one this time, because it's the one that's not congruent to the other two. So if they're equal, I can just set this equation up, that 6y has to equal 8y minus 16. Subtract 8y from each side, I get negative 2y equals negative 16. Divide by negative 2 to get y equals 8. And if I want to find n, I'll just plug 8 back in. So I get the measure of angle n equals 48 degrees when I do 6 times 8 and plug it back in. Okay. Number 3 here. Find the measure of the indicated angle. So they want me to find angle E, which is this little guy right here. Well, first, I'm going to have to kind of do some steps before I can determine what angle E is. So I've got an isosceles triangle here. So this is like number 1 that we did, where I know these are both the same, and I know that all three have to add up to be 180 degrees. So I can do 2x plus 96 equals 180. Subtract 96 to get 84. So I've got 2x equals 84, meaning x is 42. So each of these are 42 degrees. Now, this is going to be a little bit hard to see, but these two angles right here are vertical angles. So I know that they are congruent. So this top angle right here is also 42 degrees. And this little tiny triangle is another isosceles. So I'm going to make each of these small angles D and E be y. So I've got y plus 42 has to equal 180. So 2y plus 42 equals 180. So I get 2y equals 138 if I subtract off that 42. And y equals, if I divide both sides by 2, 69. Which was representing angle E. So the measure of angle E is 69 degrees. All right, last one here. We're given that angle AB is congruent to AC. I want to prove that these angles are congruent. Okay, so what we're going to do here is kind of similar to what we did with our other theorems when we proved that they were the same, as we use the triangle sum theorem. Okay, oh, I'm sorry, there's this given too, I almost forgot this. AX is bisecting angle A, so that means it is cutting it in half, so this part has to be congruent to this part. And AX is perpendicular to BC. So remember, perpendicular lines intersect at right angles. Okay, so let's see here. I might get a separate sheet of paper so we've got a little more room to work here, guys. Okay, here we go. So I'm going to shuffle this just a little bit. Okay, so we've got a lot of givens here. So you guys know how I like to work. I just kind of circle it and draw it over. That's fine. So, but we're going to kind of jump right into the proof then. So I use this word bisect to tell me something. I said then that the measure of angle XAC, so XAC, this bottom half here, is the exact same as the measure of XAB, the top half. And that is because that's the definition of bisect, right? It's cutting it into two equal parts. Okay? So then, it's a little easier for you guys to see over here. So then the next thing that I was working with was to say that my other given, that AX is parallel to BC, and I automatically put in a right angle. Well, I can state that next in my proof then to say that angle, or the measure of angle CXA is 90 degrees, and so is the measure of BXA. And that is from the definition, both of those are the same reason, definition of perpendicular. I know that perpendicular lines always intersect at right angles. Okay, well, if this one is isosceles, I know these are congruent. And I want to show that these angles are exactly the same. So I do know that this triangle right here and this triangle right here, if I kind of break that into two, each of those has to add up to 180 degrees, right? Well, I'm going to go ahead and make this be, well, we'll leave that. Okay, so I've got the measure of angle B plus the measure of angle BXA plus the measure of angle BAX equals 180 by the triangle sum theorem. And I can say the same thing for all three angles in this bottom triangle. So angle C plus the measure of angle CXA plus the measure of angle AXC equals 180, and same reason, triangle sum theorem. Okay, so now let's look at what we have in this proof. So I have these two things equal to 180. If they both equal 180, they're equal to each other. So I've got measure of angle B plus the measure of angle BXA, so I'm writing this top one down first, plus the measure of angle BAX equals, and it's got to equal this one. I'm going to have to take up two lines because this one's nice and big, plus the measure of angle CXA plus the measure of angle AXE. So I said they both equal 180, so they're equal to each other, which is the transitive property. Now I have some things that are equal, right? I can subtract off those because they both equal 90 degrees, so if I take those away, so I'm going to subtract off measure of angle CXA, and I'm going to subtract off the measure of angle, switch sides, BXA and CXA. So we're using subtraction. So when I do that, I've got angle B plus measure of angle BAX equals measure of angle C plus the measure of angle AX. That's not the one. ACX is the one I want. Okay, so, and again, up here, I said that CAX or XAC is equal to XAB, and that's these ones. So if I subtract these off, using subtraction, I'm going to be left with the measure of angle B equals measure of angle C. And remember what I'm trying to prove is that B is congruent to C. So my last step is to say exactly that. Angle B is congruent to angle C, and I showed their measurements were the same, which means they're congruent by the definition of congruent angles. All right, awesome. So we proved that why the base angles theorem works there. Hopefully those examples help you guys on your homework. Thanks for watching.